I'm Anil Kumar. Thanks for watching my videos and providing suggestions. This is for my subscriber who wants to have few examples on completing squares. Well, the search engines don't really favor me, so you could always type in my name along with completing the squares to get to my videos. In this video, I'll cover up few topics which are very important as an application for completing the squares. So let's begin with the very first one. Show that the value of 3x squared minus 6x plus 5 cannot be less than 1. It really means that this is a parabola. We want to show that this parabola opens upwards and the minimum value here, the y value here, is greater than 1, right? Or it could be cannot be less than 1 means greater than or equal to 1. This you can get by finding the vertex, correct? Let's begin. So we have 3x squared minus 6x plus 5. It is a parabola with positive leading coefficient, correct? 3 is positive. So it is positive leading coefficient. This implies what? It opens up, right? Like shown here, correct? Now we have to only prove that this point cannot be less than 1, correct? So let's do completing the squares to find the vertex. So first step, of course, is take 3 common. I prefer square brackets. X squared minus 6 divided by 3 gives us 2x. Keep this 5 away. Then we have to take half of minus 2x, right? So there is no need to take minus 1. Just take 1, right? So I'm just writing square. I need not, since 1 square is just 1, right? But it's good practice. Okay. The first 3 terms form a perfect square, which is x minus 1 whole square, and here we have minus 1 plus 5. Now we can open the bracket, so it is 3 times x minus 1 whole square minus 3 plus 5, and now we can combine the terms. We have x minus 1 whole square plus 2. So clearly, what do we have here? That gives you the vertex, correct? So the vertex is at 1 and the y value is 2, right? So in this case, y is always greater than or equal to 2. And therefore, we can say that the given expression 3x squared minus 6x plus 5 cannot be less than 1. So I hope the concept is clear, and completing the squares help us to solve such questions, right? So now let me take another example. This will be a word problem, very important word problem. Here is an application question where we are going to use completing the squares to solve the problem. The question here is, Bob wants to cut a wire 60 centimeter long into 2 pieces. Then he wants to make each piece into a square. Determine how the wire should be cut so that the total area of the 2 squares is a minimum, right? Is a minimum. So what we are given here is a piece of wire which is to be cut in 2 pieces. Let's say cut into 2 pieces. And once cut, you have to make squares from these pieces, correct? So let's say we make squares from these pieces. One square is kind of like this. The other one maybe this. Okay. The area should be minimum. That is the question. How are you going to do it? Well, my suggestion here is that we are given total length of 60 centimeters, okay? So if I cut into 2 pieces, those 2 pieces could be A and B, right? A and B. So in that case, A plus B becomes 60. But when you make area of the square, each side will be 1/4 of A, and so area will be 1/16, right? You're landing up into fractions. So what I do here is that I don't really make those as my variables. We start from variables of what we need to figure out It says determine how the wire should be cut so that the total area of two squares is minimum. So I'm saying that let these lengths of squares be x and y. So this is x and this is y. Is it okay? So I define my variable as let length of the sides of the square be x and y, correct? Now if the lengths are x and y, then the total perimeter will be how much? 4x and 4y, correct? So A will be 4x, correct? And B will be 4y. Do you get my point? So by doing so, we have avoided fractions altogether and made the question very simple. So now I could write that instead of writing a plus b equals to 60, what am I doing? I am writing 4x plus 4y equals to 60. Do you see that? So I avoid fractions totally. That is my strategy to work. It helps. Now 4 is common. We can divide by 4. So as soon as I divide by 4, I get x plus y equals to 60 divided by 4 is 15. Half is 30 and half of 30 is 15. And I can now write what y is, right? So I'm just writing here, saving some space. I'm writing y as equals to 15 minus x. Does it make sense to you? So I'm writing y as 15 minus x. Is it okay? So from here it is very clear that x has to be less than 15, right? X has to be less than 15. Okay. Otherwise this is going to be negative, correct? Okay. Now, let's read the question once again. It says, then he wants to make each piece into a square. Determine how the wire should be cut so that the total area of two squares is minimum. So what is the total area? Area of the first square is x square and area of the second square is y square, correct? So when I say total area is minimum, it really means that area A, which is equal to sum of these two areas, x square plus y square is minimum, correct? Right. So that's the total area. Now I can replace y with 15 minus x. So I have x square plus 15 minus x whole square. Perfect. We can open this up. We get x square plus 15 square. So I am applying the formula. Which formula? A minus b whole square. A square minus 2ab twice 15x plus x square. That's the formula. Combine the like terms. We get 2x square. 15 square is 225. And this is minus 30x, correct? So that becomes my area. Perfect. I don't have to write all a's, but just for the sake of writing. So what we get here is a quadratic equation. So let me rewrite this quadratic equation here. Then we'll do completing squares. So a is, in this particular case, 2x square. Rearrange the term, minus 30x plus 225 plus 225. Got it? We want minimum area. This is a parabola which will open upwards, correct? This is a parabola which will open upwards. Is it okay? We need to figure out what is this vertex again. And therefore, the best strategy is to do complete the squares. Complete the squares. Let's do it. So we'll take 2 common. X square minus 15x plus 225. And then half of 15. So let me write 7.5. Okay. Normally I avoid, but in this case, let me write 7.5 square minus 7.5 square plus 225. And that gives me 2 times x minus comes from here 7.5 whole square. So I've taken care of these 3 terms. And then let's see what 7.5 square is. Okay. 7.5 square is equal to, in decimals, 56.25. 56.25 plus 225. Bracket close. Now when you open the bracket, 2 has to be multiplied with both. So we get 2 times x minus 7.5 whole square, and this times 2 double is in decimals 112.5 plus 225, correct? Which gives you 2 times x minus 7.5 whole square plus, if I take away, this is half of that, right? So not really. Okay, so we do, yeah, 225, yeah, it is 2.5 equals to, in decimal, the same value. Perfect. So what you get here is that the vertex is at 7.5 and the minimum area for combined squares is 112.5. Well, that they are not asking for, but anyway, what they are asking for is the length. So what is our answer here? So what we figure out here is that x equals to 7.5 centimeter. That implies A, this length is equals to how much? 4 times 7.5. Do you get the idea? 4 times 7.5. So double is 30, and double is 15, and 4 times will become 30. So that becomes 30 centimeters. Do you see that? So we get the value of x as 30 centimeter. So what we get here is both are actually equal, and A is equals to 30 centimeter and B is also 30 centimeter, correct? So that is how we get our solution from here. Don't forget to multiply 7.5 with 4 because we are interested in 4x, not just x. We took x as a variable to avoid fractions, right? We totally avoided fractions in this example, and I hope you appreciate that part, correct? Now let me take another example on application of completing the squares, and that is huge, to write one variable in the form of the other. Thank you. So now here we are almost at the end of this video. This is the last example on completing the squares. We'll see how to find inverse of a quadratic function. So what I have written here is height in terms of time. So it is also nomenclature. H of t means height as a function of time. So in many examples you must have seen that height h is given as, so I'm not writing this time now, just using the variable h, is minus 5 t square plus 40 t plus 100. So it represents a projectile motion. Normally, let's sketch it here, which is kind of like this. So every now and then we come across this particular question. Now the question here is to find inverse, means this is a relation which relates height with time. So we know height with respect to time. But in case I want t related to heights like this. Do you see that? So that is the inverse of function. It really helps us to find or to answer a question that when was the height 50 meters, for example, or when was the height 125 meters, for example, correct? So do the reverse calculation. For that, again, we use completing the squares. Well, in the first part, we will figure out what is the maximum height and when does it occur. That is also answered by completing the squares, correct? So let's begin by completing the squares, and then you'll appreciate how important this method is. So we'll take minus 5 common. So we're left with t squared minus, that divided by minus 5 gives us 8t plus 100, correct? Minus 5. All my values are very simple to work with. I have avoided fractions because I'm teaching you a concept here. Okay, so half of 8 is 4. So we'll add and subtract 4 square. Perfect? Okay. Plus 100. Now, first 3 terms make a perfect square, which could be written as t minus 4 whole square, correct? So these 3 terms will always form a perfect square. The sign minus comes from here and 4 from that place. Minus 4 square means minus 16 plus 100. Now open the bracket. So it is minus 5 t minus 4 whole square, and 5 times 16 with a positive sign now, right? So it becomes 80, and that is plus 100. Correct. We can combine these two terms. So we get minus 5 t minus 4 whole square plus 180. Okay. So that tells you that this time is 4 and the height here is 180. So you get the maximum height by finding the vertex, right? And when it occurs. We are assuming time to be in seconds and height in meters, right? So I just took it in short, didn't write all that. Now, when will the height be 125, for example, if that is the question? We have to kind of do inverse, relate with time. Then how can we do it? So that is what we're going to learn now. Okay, and that is called inverse. So inverse is to relate time with height this time. Is that okay? So let's see how it is done. So we'll just copy this equation again. So we have height equals to minus 5 times t minus 4 whole square plus 180. So we'll do reverse calculation. So we can bring 180 here. So we get height minus 180 equals to minus 5 t minus 4 whole square divided by minus 5. So height minus 180 divided by minus 5 equals to t minus 4 whole square. And then we can square root this, correct? So when you square root it, you have to write plus and minus. Height minus 180 divided by minus 5 equals to t minus 4, or bring 4 this time. So we get 4 plus minus square root height minus 180 divided by minus 5 equals to t. So now we have got time in terms of height, and I could write this as, let me write it here. Time is as a function of height is equals to 4 plus minus square root of, I could write 180 minus h. I'm not doing that, but I'm just keeping it as such. It makes more sense. Divided by minus 5. Is it okay? So with this equation, given the height, we can find time, right? And it may have two values, right? Sometimes a negative value also, sometimes a negative value. So it gives you two values. Perfect. So if you want to find when is height 0, when is height 0, what is the time? Or when does it hit the ground? Well, it was easy. You could do it from here also. When does it hit the ground? Using quadratic formula, correct? But this looks like a quadratic formula, correct? Yes, it is. Okay. So you could use this equation to find when does it hit the ground, and that is when height is 0. So you can find what t is, right? So I'd like you to use this formula to answer question, when will the height be, let's say 125 meters, or let's say 100 meters, or let's say 0 meters. Okay, so you can answer this question by substituting the value of height here and calculating time. So if you get a negative value, you have to ignore it, right? Since negative value is not there, t has to be greater than or equal to 0 in this particular case. With that, we come to end of this completing the squares video, in which we have taken 3 examples where you have seen the importance of completing the squares. Of course, it tells you how to find the vertex, but that also gives you minimum value, maximum value in this case, solve word problems, and also at times sketch a function and relate the variables in different way, which we call inverse of the function. I'm Anil Kumar, and I hope you understand and appreciate it. Feel free to write your comments and suggestions, share my videos, and if you like, that'd be great. Thank you, and all the best.